Hello. Okay, now I'll move on to the next topic is the simple bootstrap loader. The bootstrap loader is the another functions of your basic loader function. What do you mean by bootstrap loader? What is the difference between absolute loader and bootstrap loader? The bootstrap loader, that the first is you should be know about the loader bootstrap loader. The loader, the first program to be run by computer, usually as an operating system. The bootstrap itself begins at an address 0 in the memory and it loads the operating system or some other program starting at address 80. You should be remember all those things point. Let me say one more clarity in this one. When a program is first turned on or restarted, a special type of absolute loader, it is called as a bootstrap loader, is executed. Now, got an idea what is bootstrap loader? When a computer is first turned on or restarted, a special type of absolute loader is called a bootstrap loader is executed. This bootstrap loads the first program to be run by the computer, that is usually by an operating system. And below figures shows and source code or it is called algorithm for bootstrap loader in SIC bar XE machine, especially for SIC bar XE machine. He written the code. Okay, always you told when a system is boot, that always is started with 0. After it starts 0, it's automatically reset that loader by using that 80 address. See, but bootstrap loader of SIC bar X edition, this bootstrap reads the object code from the device F1. Assume the same program you taken. The F1 is your input device. From the F1 device, if you start read your object code, then it enters into the memory starting at the address is 80. It's not in 0. When you start for your bootstrap loader, your memory content will be started by 80 instead of 0. After all the code from the device F1 has been entered into the memory, the bootstrap executes a jump instruction to the address of 80. That means start executing the program by the memory address of what 80. To begin execution, program just loaded. It's the instruction for our algorithm. Just loaded. The register X contain the next address to be loaded. We are using X. What is the function of X? That the X is a register is used to address to be loaded. Okay, now I am writing the program. And what is the program? I will explain by line by line. Okay, before that, you have to know about these things. Just I told it. That's very fine. Let's make it a point. Each byte of object code loader will be represented in device F1. F1 as a hexadigit. This is F1 is hexadecimal digit. And ASCII code for the character is how much? 0. That is what hexa value is 30. Should be noted. Character 0. The 0 hexa value is 30. Then it should be converted into the numeric value 0. Okay, each and everything should be always used for hexadecimal, ASCII value, binary value. Okay, now start your program. Okay, just I told this theory, boot start 0. Now putting will be start. Okay, now what will be happen? Okay, now I want to read the object code. Okay, this programs gives about how to read an object program and how to fit into your memory. Okay, just for example I'm taking. Okay, now after start address will clear A. Clear the register A to 0. Then I'm taking accumulator. The accumulator value should be what 0. Okay, now load the index register X to hash 128. The hash 128 is the decimal number. The decimal number equivalent of xi is 80. What is 80? I already told the always bootstrap loader loads the program in the address 80. For that 80, I am just setting this that decimal value equivalent to 128. After that is start 128. Now I am calling a function to read. What's a read? Okay, loop jsub get c. Okay, jsub is a subroutine. I am calling a subroutine for get c. Get c is a subroutine. Should be read your object code. Okay, don't confuse object program. Then get c is in subroutine to read your object code. The object code from your program. Read hexa digit from program being loaded. That I am doing for object code. That object code is I am showing for in this one more example. See, assume this is your object code 17202D. Okay, for example, copies the start STL return address. STL return address, then object code for that is 17202D. This object code 17202 is an object code. How to load into memory? For this, the loading to memory, I am using this one. Getc is an instruction to read each character. Each character is how to read 1, how to read 7. After performing all, how to load into the memory. For that purpose, we are using that 10 for jump to subroutine getc. I will move on to the later. What is getc? Okay, after this, remove this is for save the content of register A into S. The save the content of register into S. The shift L. Then it will do the shift the content of S into 4 times. The 4 bits will be shift left shift I am doing because that one I am taking each one is represented in binary. This is when one, the first one is I am reading this character one. This one, each one character will be represented in binary. I told it the one is represented in binary 0000001. Then this 001 will be shifted to 4 times left shift. I am shifting these things left shift for the 4 times. Then content of register A should be 0001 and the followed by 000 will be getting. Okay, after that, after shifting again jsub get c I am calling. Why I am get c I am calling? I want to read the get next XR digit. What is the get next XR digit? Now I am reading only one first time. I am reading first one. I am storing into the accumulator A. After accumulator A, I am shifting 4. That one will be converted to 8-bit binary representation. I am shifting 4 bit to left. I am puts the content will be stored to accumulator A. After that, I am move on to the read the next printed character from the object code. The next printed character is 7. That will be read it. After reading that again, that is I am what to do, that will be added the previous content of register A. The register A contains the first bit 1. Then another will be read by subroutine for the 7. That will be both are added and will be stored that value into the register X. Store the address in register X. After that I am checking TIXR. You know what is TIXR? Then add X index register to 1 and compare with it is ended or not. That ended is the whole object code is ended or not. If it is not ended, we should be go for again J loop. Okay, this loop is ended. This code is only for how to read an object code from the program. Okay, after that I want to write one more subroutine. What is getc? What happening in getc? Actually, I have written the program is 17202D. I want to read complete instruction. This instruction should be loaded into the memory. Now I am only the part of reading and should be read into the memory. Then how to read and how to convert? Actually, we need 1 byte, 6 byte. Instead of 6 byte, it should be converted to 3 byte. How this 3-byte conversion can be done by your algorithm? Now I move on to the next algorithm is for getc. What happens in the getc? This is for bootstrap loader for SIC XML. Read the subroutine. See, read the subroutine. Read the subroutine to read one character from the input device and convert it from ASCII code to hexadecimal digit value. The converted digit value is returned in register A. When an end of file is read, the control is transferred to the starting address of X. You got it? What this subroutine is reading? Read one character from the input device. One character is 17202D. Each time I'm reading one by one character and convert into ASCII code to hexadecimal digit, and that converted digit value is returned to your register A. Return to register A is this one, because each time subroutine get C is called, then when it is get C is called, it come to this part. When it is return that value, it's go to the this again A. Whatever the resultant A is come, that will be added, shifted 4 times. After shifting, again it called get C. Get C, it come to this part. It will read the next character from the object code. After returning, it's go to this program. Then finally it will be loaded into this program. This is happening. What get C will do? Okay, let's come to this one. Okay, get C, TD. You know already instruction. What is TD? The TD is a test device. The test device for input. Test input device. What is in command to check? Jump on equal. If the device is not ready, then you have to still in the loop. When the device is unequal, that loop, the device is ready. Then if it is device is ready, start read from the input device. Read from the input character by character. Okay. While reading, you have to check once again that is an end of file or not. See, when an end of file is read, you should be control is transferred to the starting address X. Whatever the character you are reading, you check with compare hash 4. The 4 is a decimal number in SIC by XE machine stored. If you read with 4, it is an end of your program. If the character is hexadecimal equal to 4, it is means end of file. It is already fixed, that one. If it is not 4, whatever reading character is 1, the 1 is not equal to 4. Let me see your program. And whatever the reading character is 1, this 1 is not equal to 4. If condition is true, EOF in SIC, then it should be go to the next instruction. What is the next instruction? The next instruction is jump on equal to 80. If it is not equal to 4, then I have to start my program in the address of what? 80. Instead of 0, should start executing my program in which address? 80. Jump to start of program, just load it. After it started, then again compare. Whatever the character you read, it should be equal to 48. What is 48? This is for the hexadecimal value. They compare 48 compared to hexadecimal. That is what should be less than ASCII value. They compare 48 to the decimal. This equivalent decimal hexadecimal is 30. That equivalent character is 0. I am checking whatever the character is read is 0 or not. Okay, if it is 0, if it is equal to 0, or if it is true, jump on less than. Whatever the character you read, the less than 30. Just skip. If it is less than 30, you should be not need anything. Just to see that one. What are the character you read? Okay, compare 48. The compare 48 with compare 48 with 30. What is 30? Is the equivalent hexadecimal. What are them character is read 1. If it is jump on less than, yes, 31 is less than 30 or not. Then if it is true, what to do? Then subtract with 48. What is the next instruction? If this true, compare 48. Yes, if it is not equal to 48. If it is less than, get, see what are the character you read. If it is less than, yes, 31 is less than, if 31 is equivalent value, your value is 30, 48 is equal to less than. Then subtract the 48 with your given character. What's the character I am reading? This is my is 1. Then 1 is an hexa value. Equivalent ASCII value for 1 is 31. Is 0, 0 ASCII value is 30. 1 ASCII value is 31. The same thing I am writing for all ASCII value. The 1 ASCII value is 31, 7 ASCII value is 37. Like that I am writing for each and every line. Just I am saying one example. The ASCII value for 1 is 31. 31 is less than 48. Then what to do? Subtract with 48. The 48 in terms of what ASCII value is 30, 30. Okay, 31 is greater than 30. If it is true, subtract 31 minus 30. 31 minus 30, that line is subtract 48. The subtract 48 is nothing but 31 minus 30. What value I am getting? That 31 minus 30 is 1. The 1 is the actual value. Correct? You got 1? Yes. 31 minus 30 is equal to 1. After that, what's your program says? After subtracting, then compare that whatever the value we get it for that, that is equal to 10. Okay, if the result is less than 10, conversion. If the whatever the value you read it, that is stored in A, that accumulator we compare with is less than 10 or what? Less than. If it is less than, return. Return is go to your this program. If it is greater than, it should be to subtract. If it is less than or not, check out. What the value you got? 31 minus 30 is 1. I told that 1 should be converted into binary. How to write binary? 0, 0, 0, 0, 0, 0, 1. 1 is less than 10? Yes. If it is true, then store that into S value. I am storing this 1 is less than 10. Yes. If it is true, what's your algorithm says? 1 is less than true, then jump on less than return. I'm returning these to your main program. What is that? Return to your main subroutine. If it is to complete, then I'm returning. After returning, what happens? It will come to A. Content of A will be copied on to S. After copied on, shift S comma L. Then left shift I am doing. That content of 000 I'm copied on to S. After shifting to S, the shift 4 times to left. After shifting, these 4 will be skipped and 0001 will come. I am appending next 00 for the right hand side. Now, the content of S is contained these value 00001, 0000 for till this line. Okay, after returning, what happens in your program? Shift L, again J sub get C. Again it's go to the read another character. Again it's come here. What's another character? The another character is now 7. Another character is now 7. That 7 is what? This one. 7. The equivalent ASCII value 37. It is not equal to 4. Yes. Then it should be compared with 48. Then 7. It should be less than. What to do? 37 minus 30 will do. 37 is greater than 30. Yes. 37 minus 30. The equivalent 37 minus 30. Then equals 7. 7 is greater than 10 or less. You are doing. That condition is true. Then content of A. The content of A is 7. 37 minus 30. That time 7 is less than 10. Yes, condition is true. If it is less than 10, just directly add it to A. If it is the after subtracting the value is greater than 10. For example, you take D. The D after subtracting. The D after subtracting you will not get less than 10. You will get 13. 13 is greater than 10. Yes. 13 is greater than 10. Then you have to do one more step. After getting the value, you subtract again 7 also. If it is less than 10, directly you take that value. Directly you take that value and shift 4 times. After shifting 4 times, I got 0. This is for A. The S is already know. The content of A is 00011. You're adding these two. Then you'll get 17. That 17 is the final answer for whatever the 17. The same things I am loaded by using an algorithm. What's your algorithms? That algorithm is this one only. See, this one only. add s comma a, then stored into that loop. Now I am reading 1 7 by using of getC. If it is less than 10, I am directly returning. If it is greater than 10, I am subtracting once again that 7 from that ASCII value, because the hexadecides contain only A to F. If it is exceeding that value, because I am subtracting F, then return sub R sub, and finally this is for input file. This is for algorithm for bootstrap loader. Always in the exam you will get write and code for bootstrap algorithm, then you should be write both the program. Bootstrap algorithm, how to write the main program, and what is the function of your subroutine, how it is will be subroutine function be doing. I'm explaining with an example, you understand that example diagram, and finally in the exam you should be write this one. Okay, this is for your bootstrap algorithm for step by step conversion for your object code program. Okay, you should be write this program. Thank you.